Hello, this is Mrs. Ward, and I am going to go over the review worksheet for sections 1.1 to 1.2 in the calculus book. So the first question says, consider the function f of x is equal to 2x squared minus 6 for the point 312 on the graph. It wants you to graph f and the secant lines passing through the point 312, and then the different x values of 4, 3.5, and 2.5. And then wants me to find the slope of each tangent line. So I drew a graph, and what I did is, can I move this? No. I'm sketching the graph. And to sketch the graph, if I put in 0, that would be -6. And so I'm going to make each line worth 3. That'll work. So that'll be -6. And then I'm just going to put in various points. So if I put in 1, that'd be -4. If I put in 2, that's 2, 4, 8, 2. Put in 3, that's 12. 4. So I get a parabola that looks something like this. I'm just focusing on that part that I can see. Then what I'm going to do is I am going to find P of 4. So I'm putting 4 into that equation. And when I do that, I get 26. So then to find the slope between the points 312 and 426 is going to be, and that'll just be 14. Switching, and then to sketch the secant line, I'm just going to stick to blue. So that's 426. So that's that point up here. Here's the point that we're talking about. And the secant line would go something like that. Just a rough sketch, not very neat, sorry. The next one, I'm going to find 3.5. So I'm going to find P of 3.5. And when I do that in my calculator, I get 18.5. So when I find the slope between 312 and 3.5, 18.5. That'll be 6.5 over 0.5, which is 13. So 3.5, 18. So 3.5 would be here. 18 would be here. Let me switch colors. Red. Sounds good. So here and here. So that would be that secant line. And not very neat. I kind of want to. And the last one is 2.5. So I'm going to find P of 2.5. So putting that into my calculator, and I get 6.5. So to find the slope between 312 and 2.5, 6.5 is going to be 2.5 will be here. So if I could do a much better drawing, what's going to happen, what should be happening, and for some reason it's not very skinny, so I can't really see. So here, so if I had this graph, does something like this, and I have this point, let's say this is my point 312, and then I did my point up here 426, then I found the slope between those two. Oh, that's a really terrible line. Then if I did this point here, which is 3.5 and 18.5, and then I drew the tangent line there. Then the last one I did, pink, was 2.5, and that was 6.5, if I'm remembering correctly. And then I have that tangent line there. So that's like a zoomed in version of what's going on. It says use your results. So that was part B, all the work down here. Part C says use your results in part B to estimate the slope. So what I'm going to do to estimate the slope of the tangent line here, I'm going to use the 2 points that were closest. So I am going to use this point here and this point here. And those slopes were 11 and 13. So I'm going to find the average of those two slopes. So I'm going to take 11 plus 13 and divide it by 2. So that's 24. And I'm going to get a slope of about 12. And that's my estimate of what the slope of the tangent line would be at 312. And then the last one says describe how to improve your approximation of the slope of the tangent line. Well, these 2 points are half a unit away. What if I would have made them only a tenth of a unit away and I would have this slope and this slope? That would be even a better approximation. And so the answer to part D is I'm going to move those points closer to where I want to estimate the tangent line. But remember, you have to have one to the left, one to the right. They should be equal distance from the point that you're trying to estimate. Okay, so when I look at this one, it looks like it wants me to find the area underneath the graph bounded by the region. So the y is equal to 1/2 x squared is that curve. The y is equal to 0 tells me that I'm above this line. X is equal to 0 tells me that I'm to the right of this line, and x is equal to 4 tells me that I'm to the left of this line. So my rectangles are already drawn, and that's half the battle is drawing rectangles. Now when I go and I do this is marked to 5, so this would be 4, 3, 2, 1. So it looks like there's 2 rectangles in every in every unit. So that means that the base of each rectangle is going to be 1/2. So the base is equal to 1/2. And then to find the height of them, I'm going to put the x coordinate in here. And being careful, the last box I'm going to draw, this is 4. The last one I'm going to draw is 3.5. That's the last one I'm going to do. The first one I'm going to do is actually going to be at 0, which means I'm not really going to have a rectangle. So I'm going to put the 1/2 outside. And then I'm going to do 1/2 times 0 squared plus 1/2 times 1/2 squared plus 1/2 times 1 squared plus, looping down here, 1/2 times 1/2, I'm going to write 3/2 squared plus 1/2 times, that's 1/2, 2 squared plus 1/2 times 5/2 squared, that's 2.5, plus 1/2 times 3 squared plus 1/2 times 3.5, which is 7/2. And I think that's where I decided I was going to stop. That's the last height that I'm going to have right there is 3.5. And this is all going to be multiplied by 1/2. So however, whatever makes you happy. Well, this first one's easy. That's 0. And then it's going to be 1/8 plus 1/2 plus 9/8 plus 2 plus 25/8 plus 9/2 plus 49/8. And I just put all those in my calculator. And I kept it as a fraction. You can do it as a decimal. It doesn't matter. And when I do all this, I am going to get as an answer 8.75. I'm wondering if any of you thought to go back to our sigma. So I can do it this way, and that's perfectly fine. I'm wondering if any of you went back into our archives of what we've learned to do this semester and put the 1/2 out here and do the sigma notation. Start with I is equal to 0, and then do 1/2, because the function is 1/2, and then I squared. And then since I did 1, 2, 3, 4, 5, 6, 7, stop at 7, so 0, 1, 2, 3, 4, 5, 6, 7, stop at 7. I could put this in my calculator and check, and I'm still going to get 8.75. I'm willing to bet most of you didn't do that, but you chose to write it out instead. Either way is fine. The next one, I want to complete the table to estimate the limit. So I'm taking the limit of that function as x approaches 0. I cannot put 0 in here because I would have it would be undefined. It would be 0. So I am to complete this table, I am going to pick up my calculator and I am going to put it in and use the graph menu trace. And I go to a graphing page. I'm going to hit the fraction key and I'm going to type in the square root of x plus 1, and I have to make sure that I get out of the square root and hit minus. Whoops, he didn't get out. See how I didn't get out? Minus 1, and here I can plainly see that that minus 1 is out over x. Hit enter. I have my graph, and then I'm going to do menu graph trace. And if I do negative 0.1, I'm going to get 0.51, negative 0.01. I'm going to keep on doing that so I can fill out my table. And when I fill out my table, my values are going to be 0.513, 0.501, and this is 0.5 going the other way. So as I'm approaching from the left, it looks like I'm going to 0.5. As I'm approaching from the right, it also looks like I'm going to 0.5. So I'm going to say this limit is 0.5. Or 1/2. Either one is acceptable. And then if you're not sure, you could keep on, you could do like 0.0001. And you'll see that it is going to 0.5. I was hoping, I don't think it would. Yeah, it's never going to round it to 0 like sometimes it does. But okay, moving on to the next one. It says use the graph to find the limit if it exists. If the limit does not exist, explain why. So the first one is find the limit as x approaches 3. Well, at 3, I have this vertical asymptote. As I approach from the left, this is getting smaller and smaller. As I approach from the right, it is getting larger and larger, so it's not approaching the same number. So I'm going to say the limit does not exist. And explaining why, I can say it does not approach the same number, or I can say that it approaches an asymptote. If you write does not approach the same number, you can use that pretty much every time. Okay, the next one, it wants to find the limit. The first one wants to find the limit as x approaches 0. So as I'm approaching 0 from the left, it looks like it's going to be -2. As I approach from the right, it looks like it's still going to be -2. So the limit of h of x as x approaches 0 is going to be -2. And then the next one wants me to find the limit of negative as x approaches -1. So -1 is here. So as I approach here, it looks like that's -3. As I approach from this direction, it also looks like -3, so that's going to be -3. And okay, the next one. Find the limit as x approaches 1. As I approach from the left, it looks like it's going to be 3. As I approach from the right, it looks also like it's going to be 3. So this limit's going to be 3. F of 1 is equal to 1. So remember, this is the case where the function doesn't necessarily have to equal the limit. 3 reasons why a function or limit does not exist. One is they approach 2 different numbers. So you could have a case where it's approaching this number, and then you have that big jump. Now the reason is this one here where I have an asymptote, and then the final reason is that graph that has that oscillating behavior. Those are the 3 reasons why your limit does not exist. Okay, number 5, it says it wants you to sketch the graph of the function f that satisfies the given values. And the most important thing to understand is there are many correct solutions, so you can have something different than somebody else. So the first one says that f of 1 is undefined. So I am going to remind myself of this. So I'm going to take out a highlighter, and at x is equal to 1, I am going to draw a line to remind me that I can't have a point there at all. Then it tells me as x is approaching 0, f of x is equal to -2. The limit is equal to -2. So as I'm approaching 0, -2, so I can be approaching from this direction. I can cut through because it doesn't say I can't equal. And maybe I have an asymptote here. Maybe, maybe not. We'll have that go like that. F of 3 is 6. 1, 2, 3, 1, 2, 3, 4. So I have that point there. And then it tells me the limit as x approaches 3 does not exist. Well, then let's say my graph comes like this. So I have an asymptote, and then I may have an open circle here because the limit doesn't exist, and then that means the graph has to continue somewhere else. And let's say it's a piecewise function, and I just put another point here, and I do something like that. That's still a function. It meets all the criteria. And it works. Let's say I did something a little bit different. Let's say I said f of 1 is undefined, so I'm still having that highlighter at 1 to remind me that I'm not going to put a point there. Then I'm saying that as the limit of x approaches 0, it's -2. So let's put an open circle here, and let's say I'm approaching -2 here. And then let's say I approach here. Let's say I just have another open circle here. And then f of 3, 1, 2, 3, 4, 5, 6, have that there. So I can go from here, put an open circle here. Then I could do an open circle down here and continue on my graph. Looks completely different, but it still meets the same criteria. So as long as you follow all these steps and you have those all accounted for, any graph will work. Number 6 says use the graph of the function to decide whether the value of the given exists. If it does, find it. If not, explain why. So the first one is f of -2. So this is asking me to evaluate the function at -2. Well, when I go to -2, I have that dashed line. That's an asymptote, which means at -2, my function is undefined. Not does not exist, it is undefined, completely different. It asked me to find the limit of f of x as x approaches -2. Well, as I approach from the left, I'm going down. As I approach from the right, I'm going up. Does not approach the same number, so this limit does not exist. Then it wants me to find f of 0. So now if I go to f of 0, that would be this point here, so that is going to be 4. Then it asks me to find the limit of f of x as x approaches 0. Coming from the left, it looks like I'm approaching like 1/2. Coming from the right, I'm approaching 4. So coming from the one direction, I'm approaching 1/2. Coming from the other direction, I'm approaching 4. Not the same number. That means that limit does not exist. Switching colors again, it wants f of 2. So f of 2, I have an open circle at 2, but I don't have a solid dot, which means that it is undefined. Then it wants me to find the limit as x approaches 2. So from the left, it looks like it's about 1/2. From the right, it looks like it's also about 1/2. It's approaching the same number, so I'm just going to say that this limit is 1/2. Then the next one, it wants the f of 4. Well, here's 4. I have a solid dot at 4. So I'm going to say, and that looks like the height of 2, so f of 4 will be 2. And then it wants the limit as x approaches 4. Well, from the left, it appears to be going up without bound. From the right, it also appears to be getting larger and larger, but it is not approaching one set number. So I'm going to say that this limit does not exist. Okay, number 7, a golf ball has a volume of 2.5 cubic inches, and it wants you to find, and it says, what is the radius of the ball? So to find that, I am going to use the formula. That's a sphere. So I'm going to say 4/3 pi r cubed is equal to my volume, which is 2.5. So I am going to find that. I did not find that yet, so let me pause. Okay, and when I do that, I get my radius to equal 0.8419. We'll do 4 decimals. So that's when the volume is 2.5. The second part says, so that's answer A. Part B says if the volume can vary between 2.45 and 2.55 cubic inches, how much can the radius vary? So the easiest way to do that is I am going to set this 4/3 pi r cubed equal to 2.45, and I'm going to set this 4/3 pi r cubed equal to 2.55. When I do the first one, I get my radius to be 0.8363. And when I do the second one, I get my radius to be 0.8475. So that doesn't answer, that tells me how much what my radius can be. To find out how much it can vary, remember this is the perfect radius right there. So if I take this 0.8363 and subtract this 0.8419, so I'm going to do that right now. I get a negative 0.0056. If I take this perfect radius of 0.8419, oh, I should do actually 0.8475 minus 0.8419. I'm going to get a positive 0.0056. So up here, my original volume is 2.5. So if I take 2.5 minus 2.45, that's going to be 0.05. If I take 2.5 minus 2.55, that's going to be negative 0.05. So in words, if my volume varies by plus or minus 0.05, because that's what I got up there, then my radius, or I should say the radius, I didn't, so we'll live with it. The radius can vary by plus or minus 0.